Okay, welcome back Science 30s to our next lesson. This is 2.3 and today we're going to be looking at naming alcohols. Alcohols are a widely used class of chemicals. We see them in lots of places such as beverages, hand sanitizer, and antifreeze. The thing that defines something as an alcohol is an OH, or what's called an hydroxyl group in an organic compound. Now, it's really important to note that not all alcohols are the same. Just because something says it has alcohol doesn't mean it's the same type, and they have a wide variety of how poisonous they are. So we can't just think of alcohol as being one thing. It's a class of chemicals. And although there's different levels of danger, all of them are dangerous and considered a poison and can be very harmful in different quantities. So even though some are often used recreationally in high amounts, they can be lethal, and other ones are not intended to be ingested at all, just like the antifreeze. And in this lesson, we're going to look at naming alcohols, and it's going to follow pretty much all the principles that we had before about naming organic molecules, except there's going to be a couple exceptions. The first one is that the suffix is no longer going to be ane from an alkane, but this is an alcohol, so the last end of the word turns into all. The suffix becomes all. The next change is that the hydroxyl, or the OH, takes priority for the lowest number carbons. So before we would number the carbons in the direction that made all the numbers lowest for our branches, whether that was methyl groups or bromo groups, we wanted the numbers lowest. But now the hydroxyl is going to take the priority. We're going to go whichever way makes it so that the hydroxyl is on the lowest numbered carbon. So that makes it a bit easier that we always want to put the OH on the lowest numbered carbon, number that in that direction. And the last part here is that the parent chain must include the hydroxyl. Even if you have a longer parent chain going in a different direction, you need the parent chain to include a branch directly to that OH. So let's look at some examples. Okay, so for our first example, we have a condensed structure here. And our first step, just like naming alkanes, is to look at finding the parent group. So this one, not too hard, it's just kind of one line. We can see that there are 5 carbons, and we have that hydroxyl group at the end here. Looking at numbering, we might think 1, 2, 3, 4, 5, but that puts the OH on the 5, and we want the OH on the lowest number. So let's switch those numbers around so that the OH, or the hydroxyl, is on the 1. Okay, so now again, 5 carbons would be pentane if we were labeling alkanes, but now we're going to change that to pentanol because this is an alcohol. Now, if your hydroxyl is on the first carbon, you could just leave it like that, but we want to indicate which carbon it's going to be on because it could move, right? We could have had this on the 2 or the 3 or the 4. So I often write it as 1 pentanol. That's a good way to write it so we know where it is. Again, if it's on the 1, we can just put pentanol. Don't have to indicate that it's on the first one, but you'll get used to seeing the number indicating which carbon it's on. There's also another way that you might see, it's not as common, but you could see this in an example question or in a textbook where it writes it as pentan-1-ol. It just puts the 1 in front of the OL. Our next example, looking at a line diagram, a little bit more complicated here, but still not too bad. We'll find the parent chain here, like this, has 1, 2, 3, 4, 5, 6. We'll look at numbering those. If we go this way, the OH is on the 5, so let's try the other direction. Remove those numbers, go this way, and it's on the 2. We want the OH on a lower number, so that looks like a better setup. So now this is going to be hexanol with an OH on the 2. So this is going to be 2-hexanol. Again, you might see it sometimes written as hexan-2-ol. Our next example, looking a little bit weirder here for our line diagram. Let's start by trying to find the parent chain. And you find the longest chain is this one here, 1, 2, 3, 4, 5, 6 carbons. But this actually isn't the correct parent chain. Even though it's the longest, it doesn't have that OH group directly connected to it. And we need to include the carbon that the OH is directly connected to. So I'm going to scrap that one and select this parent group. Even though it's shorter, even though there's only 5 carbons in that, we have the carbon now that is directly connected to the OH. So that's the correct parent group. So make sure that you include the carbon that is connected to the OH, and it's the longest one that is connected to the OH. Hopefully that makes sense for you. Now in numbering these, I put up my numbers 1, 2, 3, 4, 5. This has my OH on a low number. If we were to flip it the other way, we see that would put it on a 4, which is a higher number. So let's go back to that original numbering like this. So then we have the OH on the 2, and we have a branch that is 3 carbons. So that would be the prefix prop, and because it's a branch, it's propyl. So we have a branch of propyl on number 3 and OH on number 2. So that would become 3-propyl 2-pentanol. Okay, that's our name for that chemical. Again, some practice questions or textbooks may show it as this with 3-propyl pentan 2-ol. And for our last example, we have a Lewis diagram here, so it's a bit more expanded, and you can see that we have the hydroxyl group and then also a bromine. So let's take a look at how to do that one. The parent chain, a bit easier on this one than the last one. We just have 4 carbons, and then you may look to number them thinking, okay, well I have my bromide there on the first carbon, so let's label that 1, 2, 3, 4, and that puts it so I have a 1 and a 3. And if I was to go to the other way, then it would make it so I have a 2 and a 4. So it looks like the first way was better. But remember that the hydroxyl takes priority. The hydroxyl was a 3 the other way, and now it's a 2. We want the hydroxyl as the lowest numbered carbon, so this is actually the correct way to number it. So prioritize the OH for being on the lowest number carbon. So that's what we're going to have it, the hydroxide on the 2 and the bromine on the 4. So this becomes, we see our bromo group there, 4-bromo-2-butanol. Okay, and again, you could see it in some formats written as 4-bromo-butan-2-ol. That's it for this lesson. I hope that helped you to understand how to name alcohols. Thank you so much for watching this video, and I will see you in the next lesson.